Dear students, in this video, I'm going to discuss relation. But before discussing relation, we need to understand some of the fundamental concepts like set, order pair, Cartesian product. Also, in this video, I'm going to discuss what a domain and range of a relation with suitable examples. And this material of discussion is given in the description link, so I suggest you to get it downloaded. First, let us discuss what is set. Set is a well-defined well-defined collection of distinct objects. So we need to understand two things here, what is well-defined and what is distinct object. Well-defined means a collection which is clearly, specifically, or properly defined. For example, a set of integers. If we take a collection of integers, then set of integers are well defined because we know that only integers will belong to this set. It is clear. It is specifically defined. That's why it is well defined. Also, it is the set of the elements of this set is distinct. This set contains 0, 1, 2, dot, 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 minus 1, minus 2, dot, dot, dot. All the elements of this set are distinct, so both the conditions are satisfied. That's why set of integer is a well well-defined collection of distinct objects, and it is a set. So another example: set of real numbers, set of complex numbers, and many more. So let us also see what is the collection which is not a set. Say, for example, if you say a set of smart people, if we say S is a set of, then there is confusion, there is no clarity that what belongs to this set. Say, for example, if you take any one element, Ram, if you take any one person, Ram is a person. तो अभी राम जो है एस में बिलोंग करेगा कि नहीं, कौन सा बेसिस में आप इसको डिफाइन करेंगे, राम स्मार्ट है कि नहीं, इसको आप कैसे डिफाइन करेगा, ये तो कंडीशनल हो गया, कुछ इसमें तो कुछ क्राइटेरिया होगा ना, राम कौन सा बेसिस में ये स्मार्ट है, ये तो प्री कंडीशंस आ गए ना, इसलिए डायरेक्ट आप राम को स्मार्ट डिक्लेयर नहीं कर सकते ना. That's why what belongs to this collection and what does not belong to this collection, it is not clear. That's why. Likewise, you can see more examples of the collection which is not set. One more thing we need to understand is in a set, the position of element does not matter. The order of element does not matter. That means, say for example, 1, 2, 3. So this is same as 2, 3, 1. So if you change the position of any element in a set, it remains the same. Also, there must be no repetition of elements in a set. Okay. If there is a repetition 1, 2, 2, 3, so it must be equal to 1, 2, 3. If a particular element is repeating, so it will take only once. That's all. So in that way, we can construct a set. What is order pair? Let A and B be two non-empty sets. The order pair is a pair of element A, B, such that A belongs to A and B belongs to B, and AB is not equal to BA. So pair of element in which one element from A and another element from B will order pair if this condition is satisfied. Then we say that a pair of element AB is an order pair. So what is the opposite of order pair? The opposite of order pair is unordered pair. In case of unordered pair, AB must be equal to BA. If we flip the position, it should remain the same. An unordered pair is denoted by AB curly braces B A. So in case of order pair, we use common braces. In case of unordered pair, we use curly braces. So unordered pair is nothing but a set containing just two elements. That's all. Cartesian product of Cartesian product of two non-empty sets A and B is the product of the sets A and B that contains all the possible ordered pairs. A belongs to A and B belongs to B. So Cartesian product is the product of two sets in which the elements are ordered pairs, all the possible ordered pairs from the set A to B. That is called a Cartesian product equals to 1, 2, 3 and B equals to 4, 5. This is just an example. So what is Cartesian product now? A, B. So Cartesian product is nothing but the collection of all the possible pairs from element A to B. So first we'll combine, first we'll take first element 1 combined with the elements of B, 1 combined with 4, 1 combined with 5, now 2, 2 combined with 4, 2 combined with 5, similarly 3 combined with 4, 3 combined with 5. So these are the possible order pairs from set A to B, and this collection is called Cartesian product. Okay, 2, 3, 4, 5, 6. So number of elements in the Cartesian product A and B is equal to 6. But number of elements in A is 1, 2, 3. 3 elements. Number of elements in B is 2 elements. 2 elements. So the product of the number of elements in A and B is 3 into 2 equal to 6. So the number of elements in the Cartesian product of the set A and B must be equal to the Cartesian product of the number of elements in A and number of elements in B. A relation R from the set A to B is nothing but the subset of a Cartesian product of A and B. So it is simple. The relation is just a subset of the Cartesian product of A and B. That means the relation contains only the order pairs. So every element of relation will be an order pairs from the set A to B. Okay, so that's all we need to understand. If an element A, B belongs to the relation R, then we write A is related to B by the relation R. So this implies this and this implies this. That means if an order pair AB belongs to R, then A is related to B by the relation R. Similarly, if A is related to B by relation R, then the order pair AB must be in the relation R. These two are equivalent. Okay. Let us discuss what is domain and range of a relation. So relation is from the set A to B. Now domain of a relation R is denoted by DOM R. So it contains the first element of the order pairs. So here the first element is 1. Here also 1. So repetition will be taken once. Then 2 from here, 2 from here, then 3 from here and here. This is the domain. The range of the relation R is denoted by Rn, and which is the second element of the order pairs. 4, 5, then 4 is already taken, 5 is already taken, 4 is taken, 5 is taken. Yes, only these two elements. So the range contains only these two elements. Here you can observe that domain is the set of element which is the same as the set A. Here the range of the relation R is the set of element which is the same as the set B in this case. Now let us discuss one problem based on domain and range of this relation here. So here two problems are given. I will discuss only first the problem. The question is here we have to find the domain and range of the relation R. And the relation R is defined as A is related to B if and only if A is less than strictly less than B, where A belongs to A and B belongs to uh, B. So we are given that the problem is that A is related to B if and only if A is strictly less than B and A belongs to A and B belongs to B. This is the problem. Now solution. We need to find the relation. What is relation? What are the elements in the relation? So the relation is defined here. So we'll try to combine the elements of A to elements of B. Now, 2, 2 is paired with 3. This is true because 2 is less than, it is true because 2 is less than 3, strictly less. Again, similarly, since 2 is less than 4, we can write 2 is less, 2 is 2 and 4, one pair. Again, 2 is less than 5, so 2 and 5, another pair. So for 2 it is over. Now let us take 3. Since 3 is less than 3, is it true? No, it is not strictly less than. So this pair will not come. That means 3 will not be in the relation R. 3 is less than 4. So we get 3, 4, one pair. Again, 3 is less than 5. So we get 3, 5, another pair. So 2 and 3 over. So now let us take 4. So 4, 3. 4, this 4 and this 3. Will it be in R? No, because 4 is not less than 3. So this pair will not be in the relation R. Then check 4, 4. 4, 4 will it be in R? No, because 4 is not strictly less than 4. That's why this pair is also not there. Again, 4, 5. 4 is less than 5, strictly less. So therefore, it is true. Therefore, 4 and 5 here we have this. Now we have found the relation of this problem. Now what is the domain of this relation? Domain of this relation is the first element of the order pairs from here to two, two, from here three already taken, from here 4. Okay, this much only. So what is range of the relation R? What is the range of the relation R? Range is the collection of the second elements 3, 4, 5. 4 already taken, 5 is already taken. So this much only. So here also you see that 2, 3, 4 it is the same as set A. Set A. And 3, 4, 5 is the same as set B. So in this way, if we are asked to find the range and domain of a relation R, first we need to find uh, the relation of the given problem. Then we can actually identify the domain and range. So for second, you try yourself. It is solved. So I will give this PDF material in the description link. So I suggest you to get it downloaded. That's all.